And this is entitled, Please Stop Saying You Need Data to Start on AI. It's quite apt, that, right? And to tell us why, I'm delighted to introduce Jarno Kartela, who's the Global Head of AI Advisory at Thoughtworks. Welcome.
All right, so thanks a lot. New try. There's been a lot of good talks today on the importance of data in machine learning and the importance of data in artificial intelligence, the importance of the quality of data, and so on. Here I have the title of Let's Please Stop Saying We Need Data to Start on AI. So a lot of people will be grimacing and sort of, this is heresy, we shouldn't speak about these things. So for the next 15 minutes, I'm going to try to explain my point. I come from a company called Thoughtworks. We're 10,000 people plus. We believe that technology is at the core of modern businesses. My name is Jarno. I come from Helsinki. My main job is that I'm a dad of two. And the story for today is a rather personal one. So these are like personal learnings from the past 20 years of doing applied data science initiatives for the business frontier. My background is pretty varied. I've done a lot of stuff in telco and media, as well as retail, R&D, process industries, and briefly for the Atomic Energy Agency for the United Nations as well. Let's kick off the title of Let's Stop Saying We Need Data to Start on AI to draw a simple mental model of what specific AI solutions are there. If you think of it from two axes, first from the why one, so you have automation versus augmentation. Automation meaning that let's try to automate all of these tactical and operational decisions somewhat like you do in dynamic pricing, somewhat like you do in personalization, somewhat like you do in all of these sort of tactical things. On the augmentation frontier, you do computational creativity, you do strategic planning, you do scenario analysis. So you're amplifying whatever the human is already doing. So you're not trying to automate anything. That's one axis. That's one way of thinking about it. Another axis, and I think this is less sort of talked about, is that if you think about the umbrella of AI, there's a data-intensive focus on how to solve things. So let's just like cram more data in so that we can get better solutions out, versus a sort of small data mathematical optimization focus, where the idea is just to find the right pieces of data and do something really intelligent with it, and not try to build a data warehouse first. So that's the mental model we're going to use today. Automation versus augmentation, mathematical or sort of small data sets versus the sort of big data and data-intensive things. And what I claim is many, or if not most, of the most impactful business problems that can be solved with AI do not need data or data warehouses to begin with. It's a bold statement, but if we go and dig a bit deeper, if we think large-scale optimization, if we think decision science, if we think automated tactical decision-making and personalization, a lot of those don't actually need historical data at all. Large-scale optimization, it's mostly based on constraints. If you try to do optimization on top of historical data sets, you will not get to the optimal result, because the history of what you've done before does not represent what the optimum of that process or thing could be. So oftentimes in optimization problems, such as in the supply chain, such as in retail, such as in logistics, they only need constraints in which we try to find the optimum solution. it's not based on a data-intensive way of solving the problem. We did one project based on this sort of idea, and this was for an airport in Finland. And the core idea was to dramatically improve the efficiency of airport operations by optimizing the parking plans of the airport. So optimizing where planes go and so on, so that we can do it as robust as we can, so it doesn't snowball into chaos, and it's also as efficient as we can in terms of bus transfers, in terms of people walking about, and so on. And this was an optimization problem. Like the stuff that they've done before, the past parking plans, the past sort of things that they've done as decision-making were virtually next to no value for the actual solution, because you only want the constraint and the sort of search space in which you try to find the optimal solution. And I think we did a fairly good job. The duration of average airport-related flight delays decreased by 66%, which means for a single airport, around $500,000 in savings per month. I think that's good. If we look at another problem, or a sort of problem family, we can think about decision science. And now when you work with strategy, and you work with scenarios, and you work with the future, you work with futures planning, if you go to a CXO workshop and say that let's use the data that we have in our data warehouse to predict what will happen in the future, they will basically laugh you out. Or they will become so bored that they will actually doze out. Those are virtually the two options. What they want to work with is codified assumptions of the future, codified ideas of what are the possible scenarios we can pursue, and how can we simulate what's the best scenario for the particular problem. The world's first AI-made whiskey is a sort of simple example of this. It mostly uses out-of-organization data sets to create the best sort of tasting whiskey. And while that may sound easy, the sort of core principle behind it is more interesting. Decision science oftentimes is not related to what you've gathered as data in the past. Again, it's not a problem we can solve with the data-intensive focus. We have to solve it with a futures planning focus, and we have to solve it by codifying the assumptions of the future and taking data points of the future instead of the past. So it doesn't work if we just try to cram more data about the past into the actual solution. Computational creativity tries to explore new spaces. Scenario planning tries to explore new spaces. What's common for both is they try to simulate something based on out-of-organization data sets, and they try to simulate something based on ideas and trends and codified assumptions about the future. And finally, and this is perhaps still my favorite topic, I think around 90% of in-production personalization machines and machine learning solutions are fundamentally flawed. We cannot assume that the past data that's biased by our actions, that's biased by our marketing activities, that's biased by all of the stuff that's happened before, is somehow respective of what customers want today. Also, if you try to somehow feature engineer what customers want, you will end up in a loop where you're just constantly getting new features into a machine learning model that's not able to say what customers actually want. So, one of the main frameworks that we use for automated tactical decision-making, such as personalization or such as dynamic pricing, is that let's use reinforcement learning to solve these problems. The core idea of reinforcement learning to solve problems is that we don't take past data and try to predict what happens in the future, but we build an agent that takes actions against its environment and learns from the feedback as real time as we can. So, when there's changes in customer behavior, when someone doesn't buy your product at a premium anymore, you will learn that in real time because that action, because that feedback is taking place. If you try to do that with a basic sort of supervised learning, machine learning method, you cannot react to the change in customer demand. You cannot react to the change in customer behavior. Because you cannot assume you know what customers want based on the past data that you have lying in your data warehouse. So the only way to do proper automated tactical decision-making is not to assume that we know anything, and it is to do controlled exploration whenever we can. We did a study of this for Wiley. Wiley is like the Finnish BBC, so it's the national broadcasting company. We built a reinforcement learning system that tries to find the best possible artwork images per series for each particular customer segment and each particular context. It learns in real time, and it assumes nothing. It actually starts by knowing nothing about the actual situation. It starts off with having zero data on what of those images might work. It starts with zero data on customers, and it starts with zero data on context. We just say that these are the 4 alternatives to promote this particular series, which is Sorjonen. You can look it up on Netflix. You heard it here first. And then, based on real-time feedback, it will learn in real time. And it will learn so fast, and it will take probably 30 seconds for it to get it up to speed. And I think that's cool, because now when you start to think about it, and you think automated tactical decisions, how many are there in a business at any given time? Most businesses are doing hundreds or millions or hundreds of millions of decisions per day, and you don't actually need data from the past about how to solve that. You can actually solve that with reinforcement learning without doing any data warehousing projects. And all of this is not to say that we shouldn't build data platforms. All of this is not to say that we shouldn't focus on data quality, and all of this is not to say that we shouldn't look for better ways on how to utilize data in a company. What I am trying to say is that many, if not most, of the most interesting problems, the optimization of large operations, the optimization of decision-making, how do we do strategy, and how do we do strategic planning, how do we do computational creativity and R&D, and how do we do automated tactical decision-making, have little or nothing to do with the data-intensive focus of solving machine learning and AI problems and solving business problems while at it. They are actually just really intelligent ways of creating these learning frameworks that allow us to solve problems without starting on data first. So what I want to leave you guys with is that we still want to put a lot of emphasis on data and data platforms and data quality. But that is not a reason to not start on AI. They are 2 different problems, and you don't need to wait for the data warehousing project to end to actually do something meaningful for the business and for the stakeholders, and to actually create some outsized value in all of the different parts of an organization. Thanks for listening.